Hey guys, thanks for tuning in. We have an update on the Locomobile. We have the engine out of it. Here's the car there. And since we have the engine out and parts apart, we're starting to make things. So we'll have an update on the main bearings and the Babbitt work in just a bit. For now, let's look at valve guides. So here we are with the valve guides. And there's the guide there. You can see that they're incredibly long. They're about 5 inches or so in length, and they're worn out. I got like 10 to 15 thousandths clearance on these when it should be down more like 2 to 3. I'm sorry about the lighting, but it's really tough with the sun. So I could make a liner that slides down in there, but nobody makes just a standard liner for a valve guide that's that long to finish length. So I figure that it's going to take me about the same amount of time to make a new one as it would be to make the guide liner that would go in there. So we start with a couple processes. First, we start with what's on paper. So you take a bunch of measurements. There's our measurements there. I can also, it's easy enough just to do it in handwriting versus on a computer. I turn the shafts. I cut them to an extra length, and I turn the shaft so that they will always chuck up the same. So once I get one process going, I can just keep chucking it up into the 6 jaw there and get a repetitious cut on the parts that are not tolerance sensitive. So let's start cutting them. Okay, so now it's time to cut the taper. You'll see that on the end of the valve guide here, there is a taper. This is straight and taper. It's not a whole lot of taper, but I copied what was there. And you'll see the benefits of pre-machining the shaft here with the collar. Now the collar helps so that it can't slide in the chuck back, and it just holds right up to the teeth, and then the teeth are basically just turning the shaft. You can just keep popping them in, and you don't have to readjust any of your dials. And I mean, this is not a close tolerance. This is just a rough taper to improve airflow is what I'm assuming. So you can get away with just popping in the pieces one after another to keep making them and speed up the process and lower your cost per unit. So let's take a look at the taper attachment. So here we have our taper attachment, and you can see I have inches per foot on this side, and I have the degrees of angle, where is it, on this side. And it attaches to the carriage at that location there. This is 4 degrees or about, well, it's about 4 degrees is what I'm machining it at. So you just keep chucking them up there, and we'll cut the tapers. Okay, here we are with the piece. I've tapered the piece as we've done in the other videos, and we're at a step here. There's a 1/4 inch piece here for the spring to land on, and then this has a big taper on it for how it fits in the block. So now it's time to cut the taper, and I like to take a big cut because then you're only taking one pass instead of doing several. With the proper tooling, it lasts a long time and it's still accurate. So again, we're going to chuck it up on the taper here. I cut the end off on a bandsaw and then came in, you know, and just faced this to the proper length. The reason I use a bandsaw is that the cutoff parting tools are highly probable that you end up breaking something, and that would be a big waste of time. So let's make this cut. And I have my taper attachment on again. Down up, I know I'm on my 0. There. Hi guys, okay, now our piece looks like our original minus the hole down the center, so we need to make the hole down the center. If you take your traditional drill, which this is, pretty darn long, and you take your normal drill and you just try to drill straight, what will happen is, even just with me holding this, I can flex and bend it. So when you put it in the engine, if this is cocked like that, the valve to seat isn't going to sit very well, and you're going to have to take a lot of material off that valve seat. So you want to make this line as straight as possible. One way to do that would be with a boring bar, and that would be a good option, but the hole is relatively small. This one's blind yet, and the hole's relatively small, so the boring bar is tough to get in there, plus it's still very long. One way to do it is you center drill each side, which has a very stiff drill, it won't wiggle on you, and then you come back with a shorter drill and you finish the 2 holes off, and it gets it close enough. There's different ways to do it, and probably better ways to do it, but this is working here, and I don't have to buy any additional tooling, and it'll be done, and it'll be accurate enough. So let's do it. Okay, so now I'm going to ream the hole, and I do that in 2 stages, so I have 2 reamers that are going to need to go through there. This, again, straightens the hole going through there. It also leaves a better surface finish than what a drill would leave. Now, these are still about 0.08 undersized from what my finished bore diameter is. And the reason for that is after we 2-stage ream it, then we'll go over to the hone, and we're going to wet hone it to finish size. The reason for that is you have a cross-thatch pattern then on the inside of this valve guide, which will help carry oil to it. These do run fairly dry because they're on the exterior of the engine. It requires the driver to oil them. So that's why it's cast iron, and in my belief, why the cross-thatch pattern is so important, because the little oil or vapor that may get there, it needs to wick up there. So let's ream. Okay, here we go for our finish size for reaming. Okay, so we've reamed it. We've machined all the tolerances on the exterior, the tapers on both sides, and we've reamed it to size. And it's about, you can see that the holes are fairly straight. It's about 5 thousandths undersized. And you'll see the surface finish. So let's get this good on there. You can see that it's fairly rough, and if you really get in there, see how good I can get. You can see that there are scratches because of the way that the reamer cuts, and some of the burr, you'll get these deep gouges in there because it doesn't have like a good flute system to remove the material, as well as that it's just a cutting edge. So now we'll go to a hone with a stone, and we're going to finish this to a perfect bore size within a couple tenths. So let's go to that next. Okay guys, we're at the hone here. A couple of things. Here's the valves that we're making. and the stems. So we're talking about the stems for now, but here we are. We know from the previous segment that the ream didn't show very good surface finish. If you look at this now, you'll see, if I can get a good light here, you'll see that the surface finish is vastly improved over the previous scene where you saw the reamer leave a rough finish. So this is already honed, and I'll show you how to hone the next one and how to measure it. Now, the stem to guide clearance is about 0.02 clearance. And it's a very important clearance. You want to be equal all the way through here. You lose 70% of your heat through your valve face to seat contact, and you lose the rest through your guide to your stem. So this is very important that it's not too loose, because you won't have a good seat contact at the top. It'll rest all over the place. And if you're really loose, it's also not cooling through there. So measuring that is very important. I do it by feel. There's different devices to do it. I prefer my pin gauge here, where it gives me each gauge per thousandth to measure it, as well as by tenths. So in this sequence, I can get it within a couple of tenths. Here's my hone. You have a couple of gauges. You have your advance knob there. That advances the stone. Let's take a look at that. That advances the stone out of the hone. So the stone will physically come out. Let's watch it here. See the stone come out? And then this also works with pressure. And then I have another tenths gauge up here if I want to get more critical with connecting rod pin bushings and that sort of thing. This is something to rest your hands on, or to rest the end of the connecting rod as you work it back and forth. Well, let's measure and let's cut. So here we have the hone. Turn it on here, and I'm going to start when I have a fresh guide. I'm going to start, you wet it, and I'm going to start with my smallest go, no-go gauge. This is a 430. We are going to end at a 435. The 436 should not fit in there. That's this gauge. So, we start out. First, you don't want to be holding on to some of these things, because if they grab on that stone and turn, they'll cut you. And that's not fun for anybody. It is a messy job. So we're going to start with the hone here. And we'll take a rough cut. You know that 430 didn't fit before. You can feel it cut, and you get a sense for what's going on in there. If you're accidentally cutting a taper, or if there's a burr in there, you can feel it on this machine, and it does take a bit of feel. I activate, I can advance the stone, and I can let off of the stone here with my foot. So it's kind of like a throttle down there, and I can increase or decrease it. The oil you want cooling the stone. It's primarily there to clear crud out of the way so that the stone doesn't build up. Okay. So I can feel it. It's a good tight fit all the way through. And I can grab my next pin, 431, and see where we're at. Doesn't fit. So you know it's between a 430 and a 431 right now. Always try both ends and try to work it through. Now I know that this side is bigger than this side, so you got to spend a little bit more time. Now, a valve guide isn't so critical that you have to be within a tenth, but it's critical that it needs to be within a couple of tenths, and that's exactly what this is doing, as well as a good surface finish. So, anyways, that's how it's done to have the best surface finish on it. The cross thatch helps to pull oil up to the surface, and of course the smooth surface allows for a better bearing. And that's really all that there is to it. Anyways, thank you for joining. Thank you for watching, and by the time we're done with this, we'll have a perfect set of valve guides.